Alright, hi everyone. Okay, so today I realized I have never covered the topic of cameras in general. How I do the inside camera versus outside camera, how to switch between cameras, and how to overally make the inside camera looks good. So I've decided to do that today. So as you can see, there is now a camera inside of this vehicle and another one outside. Now, for those of you who wonders how I place the cameras, all you have to do is set auto activate for the outside camera to false. And so when you select the vehicle in the map, it'll show you the inside camera in the preview. So you can go in there. It's easier if you have more than one monitor, and then you can move the camera around, and you can see how it'll affect the view, basically. And so it's a really neat trick to be able to place the interior camera. Now, don't hesitate to play with the field of view of that camera. I've set it to 80, but you know, inside of the car view tends to be very claustrophobic, because you know, in real life your field of view is so wide that and it's kind of hard to replicate in a game, and on such a small screen that covers such a small portion of your field of view. It's very hard to replicate that. So because you know, if I did, then we wouldn't see much of the windshield, and it would be very hard to drive it. So you have to find a point where it's comfortable and it doesn't feel too claustrophobic. So that's usually the kind of results I expect from my interior view. You know, you can look down now. There isn't any character inside the vehicle yet, so we don't see any legs, we don't see the hands on the steering or anything like this, but that'll come soon enough. So yeah. Now, I did not rig the steering wheel or the needles on this vehicle yet. No, actually no, they are rigged, I'm just not using them. And so now, as you can see, I already started before deciding to record it, and I'm really not done yet for various reasons. So let's begin. Okay, first thing I should do is a toggle to allow you to switch from first person to third person under the press of a button. So setting, project setting, we're gonna add an input for that. So input, there it is. Wow, now there's a lot of input. Respawn vehicle. Okay, so into the action mapping, you're gonna add a change view. Now, and let's say we map it to the V key, because V is very straightforward for a view. Oops, I just realized before closing it that I misspelled it. That H shouldn't be capital. Okay, Cool, change view. Now we can feed that our blueprint. Wait, what? I think I already had one and I didn't see it. Oh yeah, view change. First one in the list. Already have one, so I'm gonna delete the one I just created. Okay, view change, mapped onto V. That's good. Well, hi again, Martin. Okay, so now that we have an input, by the way, we could have just pressed V and get the V key here, but it's always a good habit to map some inputs so that you can remap them in a future option menu or something. So we're gonna create a function as well, which is gonna be view change. I did view change. Okay, so we have two cameras for now, and we want to set active is active. Okay, so what this bit of code does is it gets the inside camera and it asks if that camera is active. If it is, then it's gonna deactivate it, because the not here basically always gives you the opposite of the boolean value you get. So if is active is true, this is gonna return in false, which we're feeding to the new active. So if it's active, that's gonna deactivate it. And if it's not activated, that's gonna return true, which will activate it. And so we'll do the same for the second camera, which is the exterior camera, or third person camera if you prefer. Now you probably should give some better names to your cameras and your spring arms, just so you don't get lost, but yeah, whatever. Okay, so now I spawn in the vehicle, I press V, nothing happens, because I forgot to put the function onto view change pressed. How about now? Alright, now that works flawlessly. Good. So yeah, camera switching is fairly simple, especially if you only have two cameras. So yeah, no big deal. Plus you can see I've got the lights working. I probably should do a tutorial on that too, I guess. Oh, and awesome new landscape I've created in a World Machine, just for the fun of it. Boom. I should probably paint a material onto it. Or I could also program a material that'll paint it automatically. Why not? You know, you can actually do that. With the material editor, you've got a lot of mathematic nodes that allow you to say, for example, if a polygon is at a certain angle, when you apply a different material to it, you know, stuff like this. So, alright, now what I wanted to do to the first person camera is that when you look right, to be able to look through the back window, it should actually move sideways, right? Because when someone looks back, they don't like flip their head more than 90 degrees from their body, right? And then the body does the rest. And so that move there prevents us from, you know, looking at the headrest instead of the back window. And so I'm gonna have to replicate that as well in the code, because now this is just ridiculous. So I'm gonna do that now. As you can see, I've made a look around function which has input for pitch and yaw, which are basically the axis value of both mouse input. And so spring arm is for the third person, spring arm 1 is for the first person. And so basically all I do is I add relative rotation according to these inputs, and then I set it to its own rotation, except I clamp the rotation that I want to clamp. So for example, in the third person I only clamp the pitch, you know, so that you're not able to look at the car from underneath the car. And so I do the exact same thing. I just add relative rotation on mouse movement and then set it back within some boundaries. So yep. And now what I need to do is to move the spring arm sideways when looking more than 90 degrees to the right. So more than positive 90 degree. And salut, c'est correct, hein? So we're gonna need to expand that comment a little bit. And it's always a good idea too to comment stuff. For example, saying that this is affecting the third person camera and this is affecting the first person. So I did that. And okay. Set relative location like so. I'm gonna need another rewrite node. I don't quite like lines crossing each other like that. So what I'm gonna do is I'm actually gonna. By the way, if this is the first video of me that you're watching, which is very unlikely actually, and don't know about the reroute node, you can just double click any wire to create these convenient little dots that you can move around, and I like them a lot, so you're gonna see me use them a lot. Okay, alright. So the first thing we're gonna do is grab the location of the spring arm and actually spring arm 1, get relative rotation, relative location, sorry about that. We're gonna right click the pin, split it, and split this one as well. Now the X and Z value are not interesting to us. All we want is to move the camera sideways. How am I? Yeah, too many wires. Oh, I know how I'm gonna. Okay, that looks better. Then, okay. Now what we want to do is actually, how many triangles are well for 3? You can speak French character if you want in the chat. I'm creating a card. Oh no! As soon as you get in the million, that's really bad. Really. I've got about 300,000 on this vehicle, I believe, and the import process is taking a while, and as soon as you go over 500,000, 500,000, I think that should be the maximum. Really. No, as soon as you get to 1 million and over, this is just this is gonna be a nightmare for the engine, and yeah, I think that's too high poly for a game actually. Now this might be awesome for rendering and stuff like this. This is probably gonna be really heavy on the performance in a game. So yeah, nothing in the likes of millions. And hello, Abu. Ouais, si t'enlèves le turbo smooth, puis toutes ces choses-là, aussi si t'enlèves toutes les coches dans les pneus, que tu rends les pneus lisses, puis que tu utilises une texture pour ces coches-là, ça peut enlever énormément de triangles aussi. Ça pourrait aider énormément ça. Donc voilà. Okay, so back onto this. So we want to map it basically. Oops. So map range clamped, Now the input is gonna be the rotation of the camera, and the output is gonna be the location we want the camera to be. So okay, so the location right now is minus 43 minus 43, and I guess it should be moved to the right, so positive, so a bigger value. So let's say minus 20, just for test purposes, and we're gonna feed that into the y-axis. And as for the n, what we want is the camera yaw. Oh, and so yeah, we're gonna use the camera yaw to choose a number for the location. Now in range A, we wanna say something like 70. And now range B, I believe the angle goes 160. So, alright. So anything smaller than 70 degrees to the right will be minus 43, which is the location we have right now. And when you get to 70 degrees to the right, then when you keep going, it should move the camera to the right. Should. So we're gonna see that right now. Yes, it did move. As you can see, we can see where the shoulder is on the seat, instead of seeing through the headrest. And so this is much better, and this actually allows you to look through the rear window while driving, which is always a good thing. So yeah, I believe we are done with the camera. Yeah, I think that looks good. You can even look there, look back to. Okay, so we're done with the first person camera. Now, of course, the next logical thing for me to do for this vehicle would be to rotate the steering wheel, the needles, all of that, which most of you should already have seen before. By the way, the doors are rigged too. I actually modified this model quite a lot recently. There was a lot of gaps in the models that you could just see through the model, so I've added some rubbers to fill in these gaps. Like all over the place, actually. And there are still some left. Like here, you can see. Let's see, that's a gap right there that you can see through, and that's always bad. And I took care of the lights as well. So okay, about the and I probably should make that a little bit cleaner. Now it's important as a programmer to always keep your blueprints as clean as possible for other people to be able to understand what you did. And so this is it. Also, I like to use functions a lot because you may imagine that having all of this in the event graph would make for a really huge event graph. That would be really hard to find what you want to find in such a huge graph. And so using functions just keep things organized, basically. Now, some people asked how I went ahead and made the brake lights and all of that. Sadly enough, I forgot to record it when I did it on this vehicle, but I guess I can briefly show you. Yeah, I can show you. Okay, so what I want is the construction script. Okay, so you've all seen that part, right? When I do the paint color, yeah, you should have seen it. Anyway, I get the mesh, get the material slot name, and then I find the name I know I've given to the slot I want, which give me an index to feed to that node. That basically creates a material instance, which means I don't have to create one in the content browser. And then I can use that material instance, that reference here, to set values like color. And so all I did for the brake lights is do the same thing, exact same thing, except I created a variable, you know, using the promote to variable. So I've created a reference variable of material instance that's pointing to the brake light, and another one that's pointing to the reverse light, the same way I did for the paint. And then here I get that reference from the variable and set scalar parameter for the glow intensity, and yeah, that's it. And so I can control how bright it is, because you know, a brake light is never actually off, right? When you're not braking, it still glows to make you visible to other drivers at night. And so that's why I didn't put this to 0, because it needs to glow a little bit even when you're not braking. And it's essentially the exact same thing for the reverse light. Now, how I calculate if you should make it brighter or not is this code here. You can go ahead and pause the video and duplicate that code if you want, if you're not watching the live stream actually. Yeah, I'm gonna explain it a little bit anyway. Vehicle movement has a forward speed, which I believe is given in centimeter per seconds. I believe that's the units that's used for the physics engine. So anyway, if it's bigger or equal to 0 and the brake input is smaller than 0. Oh, yeah, no, okay, if it's bigger than 0. So basically, if you're going backward and then all of a sudden you press W to start going forward, then the amount of time that the vehicle is gonna slow down, come to a stop, and start moving forward again, the brake lights are gonna brighten up because of that. So that's what this does. Kan man för saker med teorin om på l'ombre. wood. Euh, Comment faire en sorte que le matériel ne montre pas l'ombre des polygones? Je suis pas trop sûr de comprendre le correcteur. Ne pas montrer l'ombre des polygones. Ça veut dire pour que le modèle ait pas une ombre sur lui-même. So yeah, anyway, this is the essential of it. If you're going backward and then all of a sudden you want to go forward, it's gonna have to break in between. And this is basically how I handle the Boolean value that decide when we're breaking or not. And so that's it. Oh, and I discovered, but by accident actually, that if I plug this console command while having a landscape, it actually crashed the engine for me. Or I actually just freeze it to the point I have to Control Alt delete to close it. Because that landscape is a lot of collisions. And so if you execute a console command to show the collisions with that landscape there, you're gonna have some serious lags when you start playing. I mean, it'll lag to the point that it'll just crash, basically. And so what I had to do was to, I had to just go into the collisions and set it to no collision to prevent the engine from crashing, which is the reason I've set up that little box there. So and you know, I've made that little step there so that when the player walk up to the vehicle is actually the right side, the right height to be able to adjust the wheel colliders. So okay. I guess I should, now that the camera system is pretty much done. Nope. Actually, there's one more thing I wanted to do, and to the look around, and it was to okay. One thing. I wanted to smoothen out the camera rotation from the mouse, make it less rigid, but I don't want to use the rotation lag from the spring arm, because that would also mean camera wouldn't follow the vehicle. When the vehicle would turn, the camera would lag behind a little bit, and that'd be bad. So I only want it to move smoother when I move my mouse, and so we're gonna have to use a RenTurb for that, basically. Add relative rotation. I think I'm gonna have to modify that bit quite a lot. Yeah. I know how to do it. I just I just don't want to mess up everything, because that's gonna be a lot of wires everywhere. Alright, okay. First thing we should do is get that out of the way. Oh, and we're not gonna need that anymore. So that's one less problem. Like so. We're gonna need to recombine strike pin as well. So make right. Make rotator. Okay. So that's gonna be the yaw. It's gonna be the pitch. The roll is always 0. Now unplug that. Recombine strut pin like so. Okay. Oh, and of course, and this is a real mess. Alright, you know what? I'm gonna get rid of that real quick, just to get myself some space to work, and I'll put it back later. Okay, good. Now I need to plus, where's the plus, float plus float. And I need to do the same. Whoops, I actually needed to do that before the clamp. So I'll put the clamp closer, like so. Okay. And so we still need these. One for the pitch, that one for the yaw. Okay. So good. So instead of plugging that into the new rotation, but I'll do it anyway to show you that it still works exactly the same, except I've unplugged the part of the code that moves the camera. So it still works exactly the same, but now we have a rotator that we can use for a render, which is gonna help us smoothen out that camera rotation a lot. So target is the one we just calculated. We're gonna plug that here. So that's gonna be our target. Oh, and another trick I thought I could show you is, see, you have the input axis look right, but if you hit look right, you also have an axis value. That node here gives you the exact same value than this one. Alright? So if it ever becomes easier to do that, so yeah, if you ever want to avoid these ugly wires going all the way through the end of your blueprints, you can do that instead. So pitch, no, that was actually the one for the yaw. And we're gonna get the same for here. So look up, axis value, look up, good. So we just got rid of 2 wires, just like that. Okay, now current, that means we're gonna have to get relative rotation. And not split it, because we want to keep it rotator. Okay, now delta time is get world delta seconds. This is the delta time. That little node here actually gives you the exact same value as having tick delta seconds here. That value, well, that's the same one right there. So there again, that could spare you a lot of really long wires going all over of your blueprints. So interrupt speed, let's say we set 10. Alright, we now should have some kind of smoothness to the movement. And this should feel a lot more natural. Oh, I actually think it's not sensitive enough, but you can get these and multiply them. Float, multiply, float. You can multiply them by 2, for example, which would make the mouse twice as sensitive. So now, yeah, that's better. Much better. And you can also play with the interrupt speed. Let's say I set it to 5 instead of 10. Actually, there's something wrong. I don't know what, but there is something wrong. See, that's without any smoothing. That is way too sensitive. Well, whatever. Alright, so it's time to plug back our movement. Something like this. And something like this. Okay. Good. Fong shading. I don't actually know correctly what a fong shading is. I could look it up, I guess, on Google after I'm done with the live, and send you a message on YouTube. Try to help you on that. But yeah, for now I have no idea what a fong shading is. So, okay, I believe that settles it for the camera system, basically. Now I guess the only thing that's missing is having the steering wheel steer and having the speed RPM needles display the speed and RPM of the vehicle. And I really don't like the camera actually. So what I'm gonna do instead is I'm gonna undo what I just did there. Yeah. You should still keep the multiply, because eventually you'll wanna create a mouse sensitivity setting. Oh, that is so much better. Yeah, the Rinter didn't seem to smooth out the movements at all. It only made them slower for some reason. But yeah. Okay, so on to, I guess, the next part. Oh, actually, no, that's not true. Before we go to the next part, we need the mesh. Get anim instance. Cast it to the animation blueprint that we use, which is M4 anim blueprint, and promote that to variable, which we're gonna call anim BP. Good. Now that gives us a reference that we can use anywhere to the animation blueprint, so that we can change values and stuff like this. Alright. So onto the animation blueprint now. Okay. So this part you've already seen how to do it in previous videos, so I'm not gonna go over it again. Now what we want to do is transform. I'm not using any actually. Cool. So transform. Plug that in there. And bone to modify would be steering wheel. Okay, translation, remove the pin, ignore, that's good. Why is there a warning? No component to modify. Select. What? Oh, okay, yeah, it's because all the modifiers are set to ignore. Yeah. Replace existing. Now that warning should disappear. And it did. Okay. And bone space. Because that bone has a very special rotation to suit the steering wheel. So yeah. So bone space 0, 0, 0, okay. Then scale shouldn't be 8 pin either. Excellent. Setting alpha should be 1, but we don't need to display it. Rotation we could split, because we're only gonna affect the yaw, I believe. Exactly, only affect the yaw. Okay, so we're gonna need to have a add new variable steering angle right there, which is a float value, and which we're gonna feed the yaw. Alright, so now that variable is 0. Now this preview thing changed in some of the updates, because I used to be able to adjust the values here and see the results in real time. But yeah, that doesn't matter. Okay, so now I need to calculate the steering. And I'm not using the event tick yet, so we're going to use it. We're going to create a function which is going to be called update anim blueprint. So now that we have a reference here to animation blueprint, we can set steering angle, which is the variable we've just created, right? So we can set that to whatever we like. Of course, we don't want to get any errors, so we're only gonna do stuff in this function if it is valid. Oh, yay. I'm already gonna need to use the reroute node. Okay. And so how we calculate the steering angle is pretty straightforward, but I've done it before, and so because I'm a lazy person, I'm gonna copy and paste it if I can find it. Oh, right, that wasn't on this one, that was on the M5. I think. Where is it? What? Okay. I guess I had done it, and I don't have it anymore. Okay, I'm gonna have to redo it. That's cool. So, sorry, mustache in my mouth. Get the mesh. Get bone. Get bone rotation. That's in world space. I don't quite like that. Oh. Yes. Woohoo! Steering angle. Now we need to do that for both wheels. Vehicle movement, wheel setup, front. Okay, cool. So basically what that does is it gets the steering angle of both the left and right front wheels, and we're gonna get the biggest one of them, so absolute both of them, to get only positive values. And then float bigger. So we're gonna have a select float. That'll be the condition. So we need to move that around a little bit because it's getting a little bit big. Just give me a second. Hey. Okay, cool. So if this one is bigger than this one, that'll return true, and so we're gonna pick A, and so we want the value from this one in A and this one in B. Okay. Good. And that do not do anything. Oops. And 4. Okay, so changing the value here works. Oh, that's where it's been. Okay. Edit preview. And edit default. Okay. That's what I was looking for a few minutes ago. Okay, so there's a problem with this part of the code that doesn't feed any value. Oh, and I think I know what it is. Yes. I always do that. Some of you may have noticed I create a function, create all of the code, all is perfect, and then I don't plug that function onto the event tick. Alright, so we do have the steering wheel rotating properly right now, which is fantastic. Okay, now it doesn't rotate much. Thanks. Alright, goodbye, character. And have a good meal. Okay, so the reason I've actually decided to pick up the biggest value is because when you steer left, you can see that both wheels don't steer at the same angle, right? So if I steer left, the right wheel is gonna have a bigger angle, and if I steer right, the left wheel is gonna have a bigger angle. Or actually, in some cases, you know, they don't necessarily have the same angle, so we just want the biggest of both. So Victor, yes, I can totally put a character in there and show the hands of the character. Thing is, I don't have any animations yet to do that because I'm not an animator. But I've got a friend of mine working on just that, and as soon as he finishes the animation, I'm gonna be able to put them in there and show you how to put them in there. And that'll be a great addition to the vehicle blueprint, I think. And okay, now what I need to do is multiply these values, because we all know that you need to steer the steering wheel much more than 45 degrees so that the wheel steer 45 degrees. So I guess that'll have to be a multiply. and let's say we multiply it by 5, just for a test. I should actually check online what the ratio is, but I'm just gonna put a value that looks good, because all I want is to show you how to do it. That I don't want to make it perfect right now. I just want it to work so that you know how to do it. And so now that the steering wheel is working and adjustable, I mean, you can change these values however you like to make the steering wheel spin more or less, depending. I know that some rally car have like super sensitive steering wheels. You know, like the Formula 1, I believe, is just like legit that, and that's it, I think. So yeah, in case you need to adjust that, then you can just plug a variable in there, and that's it. So now that the steering angle is taken care of, we need the speed and RPM as well. And we're actually going to use the same principle for that. So we're just going to copy and paste this one, because we've already done all the work of hiding the useless stuff. So we're just going to create another variable, another float variable for speed, which we're going to feed in there. Oh, and by the way, you could totally do all this calculation inside the animation blueprints instead of doing it inside this blueprint. But yeah, I decided to keep all the mathematics, all the programming in one blueprint. So I'm doing all these calculations in there. And yeah. Sorry about that. And so I'm gonna do the speed needle just to basically show you how, and then that'll be it. So speed needle right there. So because we've selected bone space, and inside 3ds Max we've rotated the bone to have the right angle and everything, all we have to do is set the yaw, and the needle should rotate properly. And so I should actually rename that to speed angle, just to be clear. And I'm actually going to use the preview just to minus 130 seems to be about where the zeros. Maybe 132. Nope. Okay, minus 130, and then 130 at 260 kilometers per hour. Okay. So next up, we should set speed angle. Set speed angle, and that angle is going to be vehicle movement, get speed, So get forward speed. Now, again, that value is going to be in centimeters per seconds. You can totally change that, by the way, into the project settings. If you go under the yes, so units, so speed, velocity, meters per seconds. Okay, you can change that to kilometer per hour. So now every single time you get the velocity of something, it'll give it to you in kilometer per hours instead of meter per seconds. But that would actually be a quite bad idea, I believe. Because in a scientific point of view, velocity is always by default meters per seconds, while speed, which is not the same as velocity, is kilometer per hour, or miles per hour if you live in America. Anyway, miles per hour is there actually, so but yeah, I'm gonna leave it in meters per second because I use speed and velocity for a lot of other things. But yeah, you can actually change these here. Mass you can put into a lot of other things. I would be tempted to make it pounds, because in Canada we use pounds instead of kilograms, but at the same time there's a difference between mass and weight, and you measure your weight in pounds in Canada, but mass is always grams and kilograms, so I'm gonna leave it like that. And centimeters as a default unit is pretty cool as well, so I'm gonna leave it like that. But if you're an American and you model in inches in 3ds Max and you don't want to have to basically scale up every model you do by 2.2, you can set your default unit to be inches right there instead of centimeters, and that could spare you a lot of trouble. I just realized I've never mentioned it, and so now it's done. Now you know about it. So meters per seconds, we want to convert that. Oops, multiply. We want to convert that to kilometers per hour. So meters versus kilometers. So that would mean we'd have to divide it by 1,000 and then multiply it by 3,600, because there's 300 and 600 seconds in an hour. So multiply it by 3.6 should give us the right value, I guess. Actually, just for debug purposes, we're gonna print that. The string. So yeah, it's either gonna be a 3.6 or 0.36, one or the other. Oh yeah, it's definitely gonna be 0.36. Oh, that is still okay. I'm missing a 0 there. Good. Now we have our speed in kilometers per hour. Yay, totally. Wow, 50 kilometers per hour on reverse is pretty big. Okay, cool. So now all we need to do is to clamp that, or actually map range clamped. Oops. So we get the speed. We know that the speed is either going to be 0 or 260 according to this, and we want it to be either minus 130 if it's 0, and we want it 130 if it's 260 kilometers per hour. And we're gonna feed that to the speed angle and to the animation blueprint. So that should get the needle moving, unless we're going backward, of course, because that gives us a negative value. Okay, now you can see the needle moving, right? And it actually indicates the speed we're going at. So we're almost reaching 120, 130, 40. And so you get the idea. You can do the same for the RPM, fuel, temperature, stuff like that. And so, yeah. Basically, I'm just gonna repeat that process for all the needles. And what else am I gonna do with this today? Oh, yeah, right. Editable expose and spawn for both these paint colors. Awesome. Let's say I want to make that a sweet red. See? But yeah, rather than that, I could actually make it very, very dark gray instead of black, and make the car white instead of blue if I wanted. Like that. And voila. You can see that some bands, some decorations were actually set to be the same color as the paint in 3ds Max, but I forgot to do it for the back. Now, I don't know if that's actually going to be noticeable from the inside camera. Oh yeah, I'm pretty sure it'll be visible. Okay, I'm gonna have to fix that later, but yeah, whatever. And so yeah, I'm just gonna put back the blue because I really like that blue. And it looked not so good pitch black, but good. Okay. Yes, I'll leave it a little bit of gray, not too black. And yeah, I believe that sums it up for for the camera and the steering wheel, needles, stuff like that. I believe next thing I should do is rig those pedals, because whenever I get an animated character, that'll need to be done. I might actually also need to animate the handbrake for when the character pulls it and stuff like this. Might need to animate that too for the reverse and drive, you know. Yeah, that means I'm gonna have to add more bones. Yay! And yeah, I need to do something about these mirrors. Really. So yeah, I think that was everything for that video. If you have any questions, now would be the appropriate time to ask them before I end the stream. Or if you have any suggestions of what I could do for the next video. Alright. Oh, are you planning to do an auto camera reset behind the car? Oh, that's right. Like as soon as the vehicle is moving, you just boop, move the camera back to behind the car. Well, I guess I could do that right now, because that's really really fast to do. Although yeah, programming with a cigarette in my hands is pretty tricky, so I'm gonna take the time to smoke that cigarette. Before I do that, and that'll give you some time to maybe think of something else I should do. Yeah, and I'm gonna pick up something to drink, actually. Yeah, of course, Victor, when I had the camera resetting behind the car, I'm gonna add some camera lag so that you get to see the side of the vehicle a little bit when you're turning, and a lot when drifting, of course. I could also add an input on the mouse wheel to make the spring arm longer and shorter, so that you can Let me explain that real quick. You know, so that you can get further away from the vehicle or closer if you want. I just realized I also did not implement the headlights yet, although I have a specific material ID just for them. And I'd kind of like to add blinkers as well, so you know, automatically, just when you start turning, that they blink automatically, just for the fun of it. Because you know, I've got a spot for that on the side here and up front as well, so I think that could be an interesting detail to add. You know, when you're turning, to automatically have the blinkers blink just for the fun. And yeah. Okay, so a few seconds now, and I'll do that. Okay, good. Alright, so we're going to need a Boolean value first. Photo, rotate, camera. And do you actually want the camera to do that inside as well? Or no, actually I have a better idea for the inside. So look around, third person camera. Probably need to move that away a little bit. And one thing I could do as well is replace those wires with the input here, because these are the exact same values. Get look up for the pitch, look right for that, and actually get rid of those two inputs, so that on the event graph you don't have to plug these. And okay, make rod, make rotator, plug that in the yaw, plug that in the pitch, regroup that, and have a select node. So select rotator there. So if auto rotate camera is true and vehicle movement nearly equal vehicle movement get forward speed is bigger than 0, actually nearly equal 0. Error tolerance should be, I guess, 1 meter per second. Sorry about that. Set that to not. Auto rotate camera should be editable and exposed on spawn to let you choose that. And Boolean, plug that in here. Okay, so okay, so if it's false, it'll pick B, which is the rotation we've decided. And if it's true, we can set a rotation here that we want. So let's say 15 on the pitch. Alright, so I'll select the vehicle, set auto camera to true, and it's not working. Oh, yeah. Oh, okay. Sorry about that. I did that wrong. I did that very wrong. Add relative location, rotation. Okay, and that's actually here that I should have done that. So we're actually gonna split, recombine that struct in as well. Make rotator like so. That's the pitch, that's the yaw. Okay, and that's the one we should be using here in B. Okay. Oops. And it still does not work for some reason. Okay, first of all it should be -15, and this part of the code here never ever returns true for some reason. So that is true, and that gives us true as well. So get forward speed nearly equals 0. It'll give us true, so that's going to return us a false, and the end condition will be false. Nearly equal, so if it's not nearly equal 0, this will give us false. The not is going to give us true. Both these will be true, and so that'll give us a true as well. So I really don't know what's wrong with this bit of code here and why it doesn't return true when it should. Hey, I thought I had set that to true. Why is it false? Okay, good. Now as soon as the vehicle is moving, it sets the camera behind the vehicle. Okay, now the reason it happens instantly is because I did not spring arm. I did not enable camera lag. Camera looked okay. Yay. So that adds a little bit of lag to the spring arm, like so, and at the same time allow us to see the side of the vehicle a little bit. Now I believe 10 is a little bit big, so let's set it to, let's say something like 6. Woo! Okay, so that's a lot better. All right, okay. Hey Martin, I'm doing the camera automatically getting behind the vehicle when moving. So when you're stopped, you can look around, and as soon as you start moving, it resets back behind the vehicle, like that. Now, of course, if I set it to false, it won't do it at all. And I guess something else I should do is on the A add another select, basically. Get forward speed. Bigger. Okay, so if the forward speed is bigger than 0, which means we're moving forward, we're setting the camera behind the vehicle. And if it's not bigger than 0, which means we're going backward, we'll actually set it to be in front of the vehicle, just like so. So that the player can actually see where he's going backward, right? So as soon as I start backing up, you can see behind, so that you always see where you're going, right? And voila. And I should actually make that error tolerance bigger. And so that's it. You now have a camera that's automatically rotating to be either behind or in front of the vehicle when you're moving, if you chose to, by setting that boolean value to true onto the vehicle. Now you can set it to true by default, so that every time you spawn that vehicle on the map, it'll be true, so you don't have to manually select all the vehicles and set it to true. Or you can actually have it in the options menu, where the player can decide if he wants the camera to rotate automatically or not, and load that variable so that the player can decide that by himself. Now I wanted to adjust the length of the spring arm using the mouse wheel as well. like so. So what I'm gonna do is I should add, now I'm hesitating a little bit as of whether it should be 2 action mapping or if it should be an axis mapping for the mouse wheel. I'm really unsure which one would be best, and what I like to do when I'm unsure about which of 2 things I should do is I do both. So I'm gonna do both and see for myself which one is the best, basically. So axis event, add a new one, camera distance, why did you have to? That's really annoying. Every single time I create a new axis mapping or anything, it just reopens all of the others. That's incredibly annoying. So mouse wheel axis. I guess that'll do it. So mouse, no, actually camera distance. Camera distance right there. And we're gonna have to create a new function too. So functions, function, camera, distance. Yeah, maybe Paul, maybe they'll fix it one day, or maybe they won't. Like a lot of things actually. I'm not complaining or anything, but small bugs like that is just they've got so much more important things to worry about. I think I'm just gonna have to deal with it. So camera distance, we want to get the third person spring arm. And set length. So we want the length to be get length plus and that'll be camera distance axis value. Plug that in there, and that should allow us to now it does not seem to do anything, and I think I know why. Yes, again. Wow. I look so professional right now. I do the same mistake every single time. So as you can see, I am able to adjust the distance, which is taking a really long time because axis values are reaching from 1 to 0. And so I'm going centimeter by centimeter, which makes me want to multiply that value. And I actually multiply it by a negative value, because I want to reverse that. And so that could be another variable called, for example, zoom sensitivity that you could set in the option menu. But I'm just gonna put a number in there for now instead of creating another value. And so let's say -10. So instead of going centimeter by centimeter, we're gonna go 10 centimeter each time. And that is much better. Now, of course, we need to clamp that value. Because right now the player can extend the spring arm infinitely, which is bad. And he could also make it short to the point that it collides with the vehicle, which would be even worse, right? You don't want a player to be able to orbit inside of the vehicle mesh. So you definitely need to clamp that value. To a minimum and a maximum bound. For example, the minimum could be what I have right now. Spring arm. I have it at 450, but I believe it could be a little shorter than that. Not 40, 400. And I guess that 700 could be a good maximum value, I think. We're gonna see that right now. Alright, so that is 700, right? And that is 400. Which gives you a nice close-up view from the vehicle. It could, I guess, be shorter a little bit. You know, it's a minimum value, so the minimum value should always be, you know, the really minimum that should be possible to go to avoid problems. So, you know, if the player likes it like that, it doesn't actually cause any issues, so he should be allowed to have that camera like that if he wants to. Even though I don't personally really like it. Alright. Great. So yeah, there you go. Automatically rotating camera with a bit of camera lag so that when you drift and all, you can actually see the side of the vehicle. Now you could have the camera going in front of the vehicle only if the player press a button instead of doing it automatically, because having the camera switch forward and backward on its own could get annoying at some point, especially when drifting and all of that. So you may actually want to put that onto a button, but yeah. Yes, Paul, it could actually get zoomed out and zoomed in automatically as you speed up and speed down, totally, to give some more visual acceleration effect. You could add some blur to the screen as well, to the you know, how can I phrase that in English? Add some blur to the outside of the view, actually, the borders of the screen. That's what I meant to say. As you speed up, because you know, in real life, the faster you go and the more side vision you lose, right? Because everything is moving super fast. Your brain can't process the information fast enough anymore, and so your side vision gets more and more blurred out. And that is also something you could do using the speed value if you want. And that would be another really interesting visual effect to add, and to you know, just let the players see just how fast he's going, and add some immersion. And yeah, I guess it would be part of the camera system in theory, but I don't know if I want to do that right now. But yeah, one thing I do want to is remove that in here and actually put it on the press of a button instead. Yeah, Victor. I'm sure a lot of people would like it if I started a race game from scratch and showed you all of it. I'm pretty sure I'm gonna do it at some point. Yeah, I'm pretty sure I'm gonna have to do that. Alright. Now, one thing I want to do also is get that speed in kilometers per hour before checking if it's equal to 0. So that'll allow me to set the error tolerance in kilometers per hour instead of meter per seconds. So you can see that the camera won't automatically rotate unless I'm going at least 5 kilometers per hour, so I can move a little bit and whoop. As soon as I go over 5 kilometers per hour, it'll just snap behind the vehicle. And even if I'm going backward, because yeah, I believe that should be done on the press of a button and not automatically for the placing the camera in front of the vehicle. So yeah. And the way we're gonna do that is actually very simple. The way we're gonna do that is we're gonna add back the part I just removed. Like so. If it's true, that means the player wants to look back, so okay. 180 minus 15. And here only minus 15. Good. Alright, Alright, so now that this bit of code have told us that you want the camera to rotate automatically and that it should be rotating right now, the only thing we're gonna do is check, is the player pressing the button to look behind the car? And if it's not, the camera should be behind the car and not in front of it. So even graph, middle mouse button. I'm not gonna add an input just because I'm getting a little lazy there. Add another boolean value which we won't expose on spawn and call it look back. Alright, now set it to different sets. Set it to true when you press it, set it to false when you release it, and use that boolean value here. Boom. So now you can see I'm going fast enough for the camera to automatically rotate, and if I don't press that button, it won't. Sorry about that. So yeah, the player now decides if he wants the camera to be in front of the vehicle or not by pressing the middle mouse button or not pressing it. And that does not affect the interior view in any way, right? So you know, you can look to the sides even if the vehicle is moving forward. That's actually a good thing because you can see if there's another car right beside you. But what I should do is reset the camera back to be looking forward if there wasn't any mouse input for over a certain period of time. So let's say, for example, you're not moving the mouse at all for 2 seconds, and you just reset the camera back to be looking in front. So that would be here, I guess. Now I'm doing that inside a function, which means I cannot use delays at all, which is bad. Crap. Actually, I say that, but they may have. Nah, they didn't. Can I actually cheat on that? Copy, paste. Smart bastards. Okay, so I cannot use any delays. Shit. Am I gonna have to do this in a separate place and actually trigger it from there? Okay. I have an idea. I'm gonna add a branch right there. equal, oops, should check that back, equal, okay. Alright, so if both of these equal 0, we're not going to execute that part of the code at all, right? Because that would be useless, because there isn't any changes to apply. And then we'll do a separate function on the event tick. No, not onto the event tick. Actually, we'll do it here, which will be branch. Oh, and just to be safe. Because in previous updates, if you did not plug the return node, this little execute here would never be executed. And so anything that you would plug after that function wouldn't be executed ever. And so I kind of took the habit to place that return node everywhere the execution path end. And I think it's a good habit. So camera distance is done, construction is good. Okay. Hey. Okay. Retriggerable delay. Okay. No, okay. Let's say I set that delay to 1 second. And then look around, set relative rotation, of the spring arm 1 will be 0, 0, 0. Okay, so how that works is actually if you're not touching the mouse at all and both of these give 0, that'll give you a true, right? If you do move the mouse, it'll return false and reset the delay. And so you're not gonna execute that unless this returns true for a second, right? And so, yeah, we're gonna test that right now. Exactly. Boom. As soon as I don't touch the mouse for a second, it just jumps right back to looking forward. Now, same with the third person, we need to add a bit of camera lag to that. Boom. Voila. So yeah, as soon as I'm not, moving the mouse or anything, it just pops up. And yeah, the other thing, wow. I really hate it that you cannot have any delays in the functions. Because I really like functions, but sometimes you just don't have a choice to use the delays. Like here, for instance. And so location Y should be -43. For the spring arm. Hey. Okay. Okay, cool. Yeah, so that will be our little reset the camera after a second if the player isn't moving it. Now sadly I cannot put that into a function, but yeah, I'll figure out something to make it prettier. So now if I look back, voila. Oh, good. Now, I don't really like that camera lag when driving the vehicle, right? I think it's a little bit overdoing it. So I guess it should only be activated when doing that, or I could just set it to a higher value. Yeah, I think that looks good. Okay. Oh, and for those of you who might be wondering why I've actually put the first person camera on a spring arm, is because you see how that spring arm is like -10 centimeter long? That's because, you know, when you actually rotate your head, the center of rotation would be your neck, and your eyes are not directly on top of your neck, right? And so that makes the effect when looking around in the vehicle more realistic, I think. And so that camera is at the end of that spring arm. And yeah, that's it for now, I think. Alright, camera system is pretty solid. So, do you have any other suggestions? Oh, right, the camera distance with the speed. Okay, now I'm gonna use a little bit of a dirty trick, because the nice thing about Axis Event is that they constantly execute even if their value is 0. So even if you're not touching the mouse wheel, that function is still gonna trigger. And it basically triggers as often as event tick. So we're gonna use that. And so, I guess we're gonna add a plus to that. Camera distance. And what we're gonna add to it is the speed of the vehicle in kilometers per hour. No, actually, instead of making the spring arm longer, because if you don't activate the automatic rotation of the camera, you could be looking at the car sideways, and so getting further away from the car because you're going faster wouldn't make any sense if you're looking at the car from the side. And so I think what I should do is move that spring arm instead. And so I am not gonna add a plus there. And I do not need to use this function anymore, even though I should actually, because it's called camera distance after all. Okay, yeah, now that we've set a length for the camera, we're gonna set its location to be more backward. The reason I'm not using position lag for that is because it's really bad. Like, it doesn't look good at all. You know, it's very, very hard to have it not stop violently. It's kind of hard to demonstrate, but if you've tried it for yourself, you know, just go in there and enable camera lag, and you know, you can set whatever maximum distance you want it to get, but it's hard to tweak, and the visual result is kind of nah. You know, I just don't like it. And so we're gonna do our own version of that right there. So that would be set relative location, set relative location right there. So split, get, split again. Okay, so the Y and Z should remain identical, and the X should be a map range clamped. Alright, just like we did for the location of the first person spring arm. So we're going to use the speed of that vehicle. Now, spring arm location. Oh, it's actually at 0. That's very, very convenient. Okay, so 0, 150, I guess. Yeah, okay. Wait a minute. Yeah, okay. So let's say minus 90 kilometers per hour, positive 160 kilometers per hour. The value should be speed, I guess. And we're actually gonna do that. Okay, value. I just need to get the speed of the vehicle now and convert it to kilometers per hour. I should probably set a float variable for that, as I seem to do that calculation several times. I probably should set up a variable for that, yeah. Get forward speed. Okay. So now what that should do is make the camera okay, it's actually the other way around. So when you're backing off, you're getting closer to the vehicle, and when when you start speeding up, you see the vehicle is getting further away until it reached the maximum distance at 90 kilometers per hour, and then when you brake, you get back where you were. And if you if you're looking back, then that means see how the distance changes smoothly and all of that. You would not get that with position lag set up on the spring arm at all. So yeah, that's a good thing. See, as we drift, we slow down and we get closer to the vehicle. I believe that's actually a very, very nice effect. And it took no time at all to do. So, I don't quite remember who asked about this, but I hope you're happy. There you have it. And you can also adjust all of these values to whatever you like. You know, adjust the maximum distance, at what speed you should reach that maximum, etc. You could probably add a fin tip to smooth it out even more if you want to. But yeah, I like it this way. So was me. Alright, Bull. So yep, that's that little chunk of code here. Really simple, really effective. And you know, always comment your stuff. So actually, move spring arm back, according to speed. Okay. Move spring arm according to speed. What's that doing? Oh, yeah. Okay, that's cool. Change spring arm length according to speed. Okay. Yeah, I believe we're done now with the camera system. Hopefully. Unless we wanted to add some blur to the side of the screens, to the well, around the screen when we're going fast. I think that could be kind of cool. I'm not too sure I know how to do that, but yeah, I think that could be another video, because that live stream has been going for about 2 hours now. And yeah, for anyone who missed it, it's gonna be a very, very long video, so that's not good actually. So, okay, I think I'm gonna stop that live stream there. Thanks everyone for joining in. I hope you enjoyed watching me work. And I hope you learned something, as always. So, yeah, if for any reason you're not subscribed yet, I know I'm annoying and I ask you that all the time, but please subscribe, give a like to the video once it gets, you know, on my channel. When it's not a live stream anymore, give it a like, comments and all that. And I'll see you next time.